Hello. In this video we're going to talk about strings. And in C language, strings are just arrays of chars. So in principle a quite easy subject. But let's see and see what difficulties we will encounter in the language C. In C, a string is just an array of chars. And we have several ways of declaring such a string. Simple one is just to say, okay, I have a variable of the name s1, and this variable has the type char. In combination with these brackets and 10, it means that s1 is a pointer to 10 chars. So in this declaration, we've got at our disposal 10 chars, and this s1 points to the first char of this array, and the first element we can access with s1 0 and the last one with s1 9. And as we recall, if we work with pointer, dereferencing s1 would give us the same element as accessing the first element with value 0. So dereferencing s1 plus 2 would be the same as looking at s1 with index 2. And so we have two ways of assigning values, reading values, etc. So this is a very simple, straightforward way. Mind, by the way, that C does not initialize things for you. So whatever was there in memory before we took over of this spot of memory, it will still be there. So whatever we see when we try to print the content, it's quite random. So we have no control at this moment. A different way of declaring a variable is char s210 and then initializing it immediately. So now again, we got 10 spots, so 10 memory elements. So from s2 0 until s2 9. However, now we get our immediate initialization. So now we do have control about what's inside, at least about what's inside of the first 6 characters. And mind, I'm not mistaken. You would say, oh, hello, it's only 5 characters. But if you initialize, then automatically you get an end of string from the system for free. So the first 6 characters are initialized. So these are the ones you see, and then the next one will be an end of string, which we will show with \0. So the first 6 are initialized. Whatever is there in the last 4 ones, I really don't know. They're still random. Okay, a third way of doing it is saying I want to have an array of chars. So a char array. I don't want to know the size exactly, but I want to store this inside. So now the system is very kind for you. It will calculate how many chars are in here. So that's 3, 4, 5, 6, 7, 8, 9, 10, 11, and mind, end of string, 12. So what you will get is a pointer to 12 elements. So the first one S30 has H in it, and the last one S312 has the end of string in it. So now automatically you get the amount you need for this initialization and nothing else. So the first one S210, you got 10 spaces. The first 6 are initialized. And if you leave this open, so if you don't give a value, then he will just calculate the amount of chars needed, put in an enter string for free, and give that amount of memory, reserve that amount of memory for you. Then of course we could also do this. So now we just say char s4 is a pointer to a char. So now this s4 has space. Mind, I didn't draw any space here. So s1 S2, they're all constant pointers with no memory. This S4 is not a constant pointer, it's a dynamic pointer. And so it's a variable which will get its place on stack. So this S4 is a pointer with memory, it's 4 bytes, and it'll point, and now something peculiar will happen, it'll point to a constant string. So now the elements itself are constant. So these don't take space, only the pointer takes space. And this is a quite convenient mechanism if you want to work with standard error messages. So then you just define a lot of constant strings, takes no memory, and you can move through them with a variable pointer. Okay, and then of course we can make a combination. So we could have a variable pointer with a variable memory used string. And so we just use the same pointer. It was pointing to nowhere anyway, it just had a constant there. So now we say S4 gets memory. And this malloc stands for memory allocation. So what we do now is we call a function which is provided by standard lib, stdlib, which is called memory allocation. We supply this function with a value. So we say, okay, I want from you 20 bytes. If we don't specify, we get bytes. Then this malloc will return to us a pointer to this memory space. And what we want to do is store this pointer in S4. This malloc doesn't know what kind of pointer you want, he just reserves space. So to say to the system, and I want it to be a char pointer, you just typecast it. This is a typecast. This pointer you will get from malloc, which is a void pointer, you will typecast it to a char pointer. So now the types correspond. And then we have a combination of S4 with space, and it points to 20 bytes, also with space. And the first one is S40 and the last one is S419. Or we could use dereferencing. First one is S4 and the last one is dereferencing S4 plus 19, whatever you like. If we want to put something in there, we could just do an assignment, so S40 becomes H, but we could also use a string function. So like string copy or whatever. We will show some in the demonstration. By the way, don't forget, this is now your memory, you created it dynamically. C doesn't have a garbage collector, so make sure that at the end of your program or whenever you don't need this memory anymore, you release the memory to avoid memory leakages. Okay, so far. Now let's see how this works out in a program, and then we will also check the size of all these memory allocations and the length of the strings. Okay, I've prepared a small demonstration. So I've made a file, a source file, which includes standard I/O and includes string.header for the string functions and standard lib for the memory allocation functions. So what I've done is just declared some examples. So I have here a char S110. So this S1 points to 10 elements. So S1 points to 10 chars with S10 to S19. So if I ask the function print S1, percentage S means that he will print whatever he sees until he reaches an enter string. So if I don't initialize, it's just chance when he will stop. Size of S1 is the size of this array. So hopefully we will get an answer 10. String len is a string function, so it's from the string.header file, and this will just calculate the chars inside the string array until it reaches an end of string. So the string len would be undefined at this moment. Maybe we're lucky and we would get 0, maybe there's already something, and then we can get any value at random. Second one is S2, which had the initialization, so then the first characters were filled until the end of string. So size of S2 would still be 10, because we declared 10 chars, but the string len will be 5. So he will count the characters until he reaches the end of string, and he will not sum up the end of string because he knows that's not really part of the word. Then for the third one, this was a real-time initialization, so how are you was 11 chars, so that means S3, size of S3 would be 12, not 11, 12 with the end of string, 9, 12. And the string len would be 11, because he will just give you the real characters. Then we have S4 pointing to a constant string. So now we get something funny. If we print this S4, we will see the text constant string until he reaches here the end of string. But the size of S4 will not be the size of an array, because this S4 itself has the size. It's a char pointer with a real memory package. So the S4 size will be 4 bytes. String len S4 is again just counting the number of characters. So that would be 3, 4, 8, 9, and 6. That would be 15. Then we allocate memory, so we allocate 20. If we then ask the size of this S4, then again it would be 4. And the string len, that would be really dubious because we didn't initialize it. So the string len would be a question mark again. And then at the end we free the memory. So let's see how this works out. So let's compile. CL welcome.c. Okay, then we got an executable and let's run it. Welcome. So we have the first one, S1, size of S1 is 10, string len is 3, but I really wouldn't know, so there's something very dubious here, but it's not initialized, so it's just chance what we see and when the first end of string is encountered. For the second one we had hello, so the size is still 10, that checks, and the string len is 5, it's also correct. Then the third one, how are you? Size 12, because we want to have 11 chars plus the end of string, and the string len will be 11. Constant string, size of S4 will be the size of a pointer, so that's 4, and the string len will be 15. Okay, and then we got the S4, size of S4 is still 4, and the string len is 1, because apparently in my random memory we have a D. Okay, that can be E. So nothing spectacular. This all works out. Okay, so far this video on strings. In the next video we're going to work with some functions on string, and we're going to look at a main with parameters. See you next video.